about ancient computers and what you can do with them and how you can hack with them and hack on them and so on and so forth. So, can my panelists introduce themselves from left to right?
Me? Oh, hi, I'm the Cheshire Catalyst, Richard Cheshire, and I even brought one of my retrocomputers with me, my Model 100, which I've been using this entire trip. I'm keeping track of all the neat t-shirts I see, some of the URLs I pick up along the way, and I'll be putting them on my website later.
Okay, hi there. I'm Sam Nitzberg. I started playing with computers when I was rather young. I've stuck with them. I'm a computer security specialist, typically for defense firms. And I'm going to be talking a bit about some machines and some neat little things, and I'll pass it on to Bernie S.
Can you hear me?
Yes.
Okay. Gotta speak a little closer.
Okay.
I'm Bernie S., and I've been addicted to playing with computers and electronics since, I guess, early 70s, and built my first computer in 78. And I just brought a few interesting artifacts that might make a few people here reminisce.
So, who wants to start?
I have one comment. I just got an email. Today is the 40th anniversary of the first transmission via the Telstar satellite.
Oh.
Cheshire, can you hum a few bars of the Telstar song? That was actually a hit tune in 1961.
Oh man, they really must have been starved for music.
About a satellite.
Yeah, so who wants to start? Bernie wants to start.
I guess I want to start. Okay, let's see. I think probably most of, well, depending on the age of people here, people's first exposure to computers was actually a calculator, and maybe even later a pocket calculator when they made them really small. By the way, out in the RetroComputing neighborhood, out on the second floor, we have besides RetroComputers a whole bunch of retro stuff. But there's the oldest calculator I have ever seen is out there. It's made by Wang Labs. It's actually a computer network. It's a central processing unit with 3 terminals plugged into it that do scientific calculations, and they have Nixie tubes as displays. I don't know if anybody here is familiar with Nixie tubes, but each character in the numeric display was a vacuum tube that had 10 fully formed wire sculptures inside it, each representing one of the 10 digits, 0 through 9. And of course it was a vacuum tube with some fluorescent gas inside, and they would apply a high voltage to one of those wire sculptures, which would then illuminate that display, and it was very beautiful. So I wouldn't be able to really show it here, but if you go down to the second floor sometime today or during the weekend, check out the Wang scientific calculator computing network thing. It's unfortunately it's not fully functional, but you can get the displays to work and play with some of the buttons. And I think Nixie tubes are probably by far the most beautiful and most highly readable electronic calculator display ever made. They're used in frequency counters and other test equipment too. But if you've never seen a Nixie tube, you owe it to yourself to check it out. Related to Nixie tubes was another display technology called vacuum fluorescent, and I have a very early pocket calculator here, made by Panasonic around 1971. I don't know if you can. Yeah, here we go. I don't know what's up with the colors on this thing. It's really kind of purple. You got to really see this thing in its full color glory to appreciate it. But anyway, what's interesting about this calculator, besides the fact it's older than most of the people in this room, is that it's extremely well made. This is back in the day when quality counted, and these things were built to last. As you can see, this thing still works. I found this at a ham radio flea market a couple of months ago. Paid $10 for it, which was a lot less than it originally sold for, but it's probably worth a lot more than that in the collector's market. Anyway, what's kind of interesting about that is the keys on this are each, I don't know if you can see them. You see how far they move in and out? They move in and out like your computer keyboard, but there are no wires connected to these keys. There's no actual switch contact connected to these. Behind each of these keys is a magnet, believe it or not, and behind the magnet is something called a reed switch, which is two very thin pieces of metal in a tiny vacuum cylinder, and when you get a magnet near it, they touch each other like this. So that results in a very high reliability. The contacts would never wear out really because they're sealed in a magnetic chamber, in a vacuum chamber, but a very tiny one, about the size of a match head. And you don't suffer from the key bounce problem you had with some of the early computers. Even some of the early microcomputers like the TRS-80 and the Commodore PET. A lot of times you'd hit one key and you'd get 2 or 3 bounces. In fact, I think the original TRS-80 Model 1, it was such a problem, this key bouncing thing, that they had to not do a recall, but they had to ship a cassette tape with a subroutine that would debounce all the keys. And this calculator came out 10 years before that. Well, I guess about 7 years before that. And it never had that problem because it was better designed than Radio Shack's TRS-81. But one of the other interesting things about this calculator is it calculates things slower than you might be used to seeing something calculated. I'm going to take the square root of 6,666 and see there's a slight delay. I don't know if that was too noticeable. But on some of these calculations, let's see here. Yeah, that's a good one. If I take the square root of 6, watch this. You see that? You actually see the calculation happening, which I think is pretty wild. You don't see that on a calculator you get these days. Vacuum fluorescent display. One of the unique things about the vacuum fluorescent display in this is unlike a lot of vacuum fluorescent displays, each character here has its own tube, as opposed to all the characters being in one tube. And if you can look at the 4, there's a separate segment off to the right of the 4, which makes it a more readable 4. I don't know if we can get that in there. This may be boring to some of you folks. Stop me if it's too detailed. That's enough with this particular calculator. And this has become my favorite 4-banger calculator, as they called it. I have another calculator that might interest some folks. How many people remember biorhythms? Biorhythms was a really big thing. Cheshire remembers biorhythms, don't you?
Yes.
Did you ever calculate your own biorhythm?
Well, I had a program for the Altair 8800.
Excellent.
Yeah.
Yeah. For some reason, when microcomputers first became available, generally in kit form, or you design it yourself, one of the most popular applications was calculating your biorhythm, your emotional. What were the 3 cycles here? You had your physical, intellectual, and emotional. P, S, and I. I forget what the 3 were. But this calculator, boy, this is a really lousy display. This calculator here, the Cosmos 1, came out in, let me look at the manual here. Oh, this is a great little manual too. You got to see this thing. You got to see the styles in this. Why is it some days you feel like $1,000,000 and others like small change? And it goes Introduction to Biorhythm. This calculator was a special purpose calculator. It was a 4-banger. You know, did your 4 functions, but it also would do this biorhythm thing, which is people used to pay a lot of money to have their biorhythms calculated. You know, like professional athletes, and you know, it was a big thing. Everybody believed in it. I think it's kind of hocus pocus, but anyway, you can't read this text, but I'm going to read this to you because this is pretty great. It says the IBM 360. The IBM 360 computer can give you all the biorhythmic calculations you want. It's as big as a room and costs about $2 million. There's the picture of the 360 mainframe. And then it says,
of course, a picture of the tape drives because they move.
Yeah, there you go. You see the tape drives. Then there's the Biocom 200. The Biocom 200 computer can monitor your biorhythm too. It takes up most of your desktop and costs about $3,000. This was dedicated just to, boy, what a crappy display, but this was just for biorhythm calculation only, this thing. And then the Cosmos 1 can give you any biorhythmic information you need. It can chart your physical, emotional, and intellectual cycles. It can alert you to critical and mini-critical days. It can give you compatibility ratios and has 2 memory banks. Anyhow, I did a check on this thing. I was curious as to whether it was Y2K compliant because it was made back in the 70s. And believe it or not, it is. I don't want to waste too much time here and actually start calculating someone's biorhythm here. It would be cool if we had time. But anyhow, this calculator, unlike a lot of old stuff I've got, is Y2K compliant. So there's some good engineers who designed this stuff. This had a custom chip for calculating biorhythms. And if you saw this thing up close, you'd think it was a very beautiful machine. It looks very suspiciously styled like a Hewlett-Packard calculator, doesn't it, Cheshire?
Hewlett-Packard or Texas Instruments, but mostly Hewlett-Packard.
This, I mean, with the sloping keys, it looks exactly like an HP, but it wasn't.
I first thought it was an HP 35 when you pulled it out.
Yep. Anyhow, along the lines of also pocket calculating devices, this came much later. This was in the mid-'80s, and zoom out here. Whoop, zoom out as far as we can go. Believe it or not, this thing is not much bigger than a deck of cards. It was the Hewlett-Packard 100LX. I don't know if I turn this on, will you be able to see anything to display or not? Probably not. Oh, there we go. Oh, guess what? The battery's died. But anyway, this machine had 1 megabyte of RAM, which is actually a lot, and it supported the DOS 3.1 operating system, which is pretty cool. It had a serial port, and I used this for programming two-way radios for quite a while. Motorola two-way radios, like Security's using here at H2K2. But anyhow, this was it's still one of my favorite pocket computers because it has the flexibility of a text interface, and you could write your own programs for it, and it's not a bulky bloated operating system like Windows. And it also has a RAM drive I put into it of 40 megs, so it's a very powerful little pocket computer from the early 80s. And this isn't exactly a computer, but it's a pretty interesting pocket keyboard type device called a TDD. And I don't know if you've ever gone to a airport or bus terminal or something and seen a payphone that has a picture of a handset with a keyboard under it. That's for people who are hearing impaired to communicate. And I'm going to let you hear what one of these things sounds like. This is a pocket terminal, battery powered. You can walk up to a phone and communicate with another hearing impaired person who has a similar device. I'm going to say...
Now, notice also, single tone, and it only gives a tone if there's a 1-bit. Zeros are silence, including the spaces between characters and words. This means you can set up a conference call between people using these devices, and one person can type, everyone can hear the signals coming across. It'll display on all the terminals, and you can have a conference call among TDD terminals.
These things are a lot of fun, actually, and you can get a chance to play with a TDD, not a pocket one like this. Found this at a flea market for $10. Folds up about the size of a videotape. If you go to next time you see one of these things, you might want to write this phone number down. Go to a payphone and take the phone off the hook that has the TDD built into it, and dial 1-800-855-1155. And the TDD won't slide out of its magical motor-operated tray until it hears a carrier tone at the other end, and here's the frequency shift keying, and then this tray will magically slide out, and you'll see an AT&T operator manually typing. This is AT&T operator number so and so. How can I help you? And you can talk with her by keyboard, and she won't do free directory assistance lookups, unfortunately, but you can argue with her on with the keyboard if you want, or just social engineer. I just try to social engineer them and try to get them to do things, and it's a lot of fun.
Can you ask her to go voice?
No, you can't ask them. Well, it depends. Some of them actually are hearing impaired. One of the interesting things, if you have a directory assistance lookup done by them, you've got to give them a credit card number, and what they do is they put you on hold, and then they pick up a regular phone. If they're hearing, I guess, or not hearing impaired, and they call another directory assistance operator. Do you believe this?
Oh, I do, because I'm a directory assistance operator in real life.
You get calls from these people?
I get calls from TDD Relay with directory assistance requests.
Is that insane or what?
Well,
Wouldn't you think it would make sense to integrate that all into one terminal?
No, you have to go through an operator because of the way our directory assistance terminals are set up. They wouldn't want to do a direct lookup on the database. Now, it's possible that they could go to an internet system because there are a number of directory services on the internet. There's realpages.com from Southern Bell. There's anywho.com from AT&T, superpages.com from Verizon. And it shouldn't be that difficult to integrate them using PDD terminals.
It just blew my mind when an operator I was in conversation with. Oh, by the way, another fun thing you do with the relay services, which kind of off the topic, but I don't want to take up much more time. I'll only need a couple more minutes. Is you can call one of these TDD operators with one of these things, and they will call a hearing person for you and act as a liaison. Well, a few years ago, I was actually suffering from laryngitis and needed to call my girlfriend, so I used that service, and it worked pretty well. And we decided to see how far we could push the envelope with this operator, which under federal law was required to not edit or otherwise change what you're saying as far as what you're typing. You had to accurately transcribe it. So we got kind of hot and heavy with that conversation, and you could see her pausing. You could feel her pausing as she's retyping this stuff. It was you could almost see her fingers trembling as she's typing this stuff. It was a lot of fun. How many people recognize this stuff? Raise your hands. All right. Thing on your right is an IBM Selectric, which is a element ball. They call it golf balls. It look like a golf ball. These were by far the most brilliantly designed typewriter ever made. I mean, the keyboard had the most perfect feel. IBM spent millions of dollars for the most ergonomic keyboard, the perfect feel. Why they never carried that over into their PC line, I have no idea. It was just the stupidest decision they ever made. They would have sold a lot more computers if they kept that Selectric keyboard design. Anyhow, for people who don't know how these work, this ball would actually rotate, and as you typed, this thing would fly around at high speed. You can even see it move. It was moving so fast. And it would slam against the ribbon and the paper and give you extremely high quality, letter quality text. And you could buy these golf ball elements. This is Courier pitch 12, and you get them in all kinds of crazy fonts. And anyhow, these days are over, but I really miss a Selectric. In the early days of PCs, you remember this, Cheshire? The most lowest cost letter quality printer you could get in the mid 70s was to get an IBM Selectric typewriter. And a company made a kit that would lay down over the keyboard. It had a bunch of solenoids on it that would interface to the serial or parallel port of your homemade PC. And it would actually robotically type on the keyboard of the Selectric for you as it was getting data off your homemade computer. And letter quality, and it cost just the price of a typewriter, which you already probably had, a Selectric. And I think the kit was $500 for the robot. And you would have to spend like $5,000 for a letter quality printer. The last thing I want to show is a font module for the IBM QuietWriter 1, which was an early letter quality printer. And before the days of soft fonts, as in software fonts, it was firmware, and you'd have to buy your fonts in a cartridge like this from IBM. Very well designed cartridge. You plug it in, and this was here we go. If you can read that. Probably not. It's Prestige Elite, and has the IBM part number on it. IBM stuff was extremely well designed, but I think they just got out of the PC business, didn't they?
Yes, they did.
Well, and one last thing is I brought my laptop computer with me, and I'll show it to you. It's in my laptop case. Rather an early laptop computer.
All right.
My laptop computer.
6502?
That's right. Cheshire knows what this is. See if I can zoom out on this thing. Boy, this is really highly distorted. This is a Sim 1, as opposed to the Kim 1. These are early 6502 single board microcomputers. This was built in 1977. By Steinertech Systems Corporation. This was really the Rolls-Royce of 6502 computers. 6502, by the way, was the computer that was used in the Apple II computer and the Apple I, but not too much. I used to have an Apple I, actually, many years ago. I wish I still had it. It had all of 2K of RAM. It used static RAM, 2114 chips, which I later reused as something else. So it had 2K of RAM. You'd be surprised back in 1978 what you could write with 2K of RAM. That was, if you could fill 2K, you could fill all your memory with, you were a pretty amazing programmer. You could write a bunch of bad code, but if you could write the art of programming was different then. You had to really learn how to write efficient code to fit into expensive memory. Because this memory, 2K of memory, cost hundreds of dollars. So is that a question? Okay, I'm going to let everybody go on to this because I probably monopolized too much time. And thanks for looking at my old junk.
Well, I'm kind of a little short on time because you got a late start. So,
I've got
Sam, do you wanna
12:30.
go next?
Sam, yeah, I'll go, and I'll make sure I leave you half the time. Okay, I'll try to move this along. Okay, I've got a few things that I'll be discussing. A little bit about homebrew systems, a little bit about Apple II hardware hacking, and a little about spycraft. Now, I'm focusing a little on hardware hacking. Now, homebrew systems, a lot of you may remember, or some of you may remember, Heathkit used to sell computers, which were kits. You'd assemble them yourselves.
They were great kits.
And if you got stuck, it'd actually help you out, and there were hundreds and hundreds of pages of how to fix things that when they didn't work. And what was nice about these, they had a certain degree of style. For example, the Z80 Zenith system had an octal keypad on it, and that's how you entered everything. Not too different than the one we just saw for the 6502. Now, if you wanted to get fancy and hook up, say, a terminal or disk drives, you got a PROM, you put it in, and you could type in the hex address of the beginning of the boot sequence instructions, and it would then give control of the drive and start booting. Also, they actually made a little robot where you could program it and have it move around and follow instructions.
The Hero 1.
Yes. I was trying to remember the name of that thing.
There was a Hero 2000 later, but the Hero 1 was pretty cool.
2000 remembered. Now, what's interesting actually is much later we see things like tactical entry robots being developed for demolitions removal and hostage negotiating teams. And I like to think they're kind of distant cousins and may have at least been inspired by people playing with these earlier robotic systems with computer attachments.
I think a lot of people were inspired. I read a book about I found an old book about Heathkit at a flea market a while back. They tried to get this, the first one they made, they tried to, they were getting a lot of publicity. All the morning talk shows were trying to get it on, and because it was really cool. It was the first home robot you could buy. It was in kit form, but you still had to buy it. Anyway, they had trouble getting this thing through airport security even back in the late 70s. So they got tired of having to be delayed through security every time. So they wrote a little subroutine that would, there was a light sensor in the Hero 1, and they built this custom crate for it. So they wrote the subroutines, whenever they opened the custom crate, it would see the light, and it would move its head back and forth and say, "Boy, I'm sure glad to get out of that goddamn box." And the security guys would just bust a gut when that would happen. They just okay, go ahead through. And it saved them hours getting this thing through the airports every time, the development team.
Now, one thing I'd like to mention actually is a computer or a homebrew system doesn't have to be complex. It doesn't even need a formal LED display in terms of full numbers. A friend of mine built a system where you had your memory, your keyboard decode, not even keyboard decoder, you had a series of toggle switches to specify memory address, and a series of 8 for value. And it had a go button or a data button. And that's all you need. You can enter addresses and values, which can be used as instructions or data, and you tell it go. And you had little LEDs would be used to display. A computer can be that simple. Now, I was going to show this earlier, you also have, in terms of hardware hacking, some things that are pretty much taken for granted now are one-point hacks, like brushing wire across a surface and letting it hit another contact to represent data would be a neat hack. Well, that's how you get punch cards.
Put a white one on, see if it's any better. Boy, they're hard to...
Yeah.
But
so,
one's better.
Those are actually a neat hack initially. A little distance from the jack or boom. Now,
your utility bills used to come on those things, and they used to say on the envelope, "Do not fold, spindle, or mutilate."
And some people
did that. And you could actually punch those out, and you could actually hack your phone bill by punching holes in those cards that you weren't supposed to.
Now, in the Apple II world, there was a microphone capability. They had an I/O port for data, but you could hook up microphones and play with it. And you can put this to different types of use. Now, currently, if you hook up a microphone to your PC and you do 44 kilohertz sampling, you're looking at 10 megs a minute. Well, you had to use assembly back then at getting kind of decent rate, and you probably recorded 10 seconds of data and played with it. That was it. I found my own use for this. Thank you. I used it to break copy protection. You could load up certain games or other programs which modify the disk operating system, and what you could very well do is when you break out of it, you have no way to write to a clean OS. So what you do is You kick it out to the tape port, is dumping memory blocks, boot into clean OS, and load it back in. That's how I got Centipede. One thing which I like is an idea that there are a lot of things you could have done with old systems for hacking or hardware playing, which you can still do. You can make an improvised light pen without too much difficulty. A very simple kit, where I got schematics and I improved their software, is you could take a big pen, put a photo Darlington transistor at the head of it, run wires out, have a little sensitivity switch, and maybe 2 transistors, and you have a light pen. All you need is software to make different parts of the screen blink for different options. You check the timing. When that part of the screen is blinking and it sees a signal, you know you've found the source or the selection. Well, back then, when I made this device, they were $300 in stores. You could build one, though, for about 10. It was a lot of fun, but you could do that on any system. You could take an IBM PC and do it. You could do it on a System 370, a Commodore, or, I don't know, possibly the Model 100. I'm not sure. Yeah, it lights black, so you use black for your selection.
Right.
Lots of people made another form of hardware hacking. People cloned Apple computers. The Russian Agate, it's one of the more notorious ones, and that went for around $2,500 to $3,500. Lacked some features in the original models, and I've even heard it costing up to 17 grand, but it ran for around 3 grand. Also, anyone could copy their own if they could. The hardest part, really, besides copying the PROM chips, which isn't a big obstacle, is laying down the circuit board. But if you had patience, you could wire wrap it. It would actually work. You didn't get into super high-speed circuits.
There was the Pineapple was one of my favorite Apple II knockoffs. It was a big, huge business in bogus Apple IIs.
Okay, and I'll just mention quickly some Apple II sites for anyone who's interested. There's apple2.org, apple2history.org. I have a schematic from them, which is nice for the Apple I, applefritter.com, and there's a site on hardware hacking, like how to turn your Apple GS into a portable, and it only involves a Dremel tool, a little effort, and some care. There's also an Apple II news group.
Sacrilege.
There are some other things that are very interesting. I think the most complicated manipulation I have found yet for an Apple is called a flash intervalometer. And this was done with a 40-page technical paper, and someone made a spinning mirror device. So you could, for example, have drops of water or a bullet go through something, and you would get it in time-lapse photography on a single image. Just type Apple II flash and intervalometer, it'll come right up. But in keeping with the notion of this light pen, there are other things. For example, you could hook up a thermistor, a variable resistor, changes resistance based on temperature, and hook it up to any computer, and you have a temperature gauge. Now, it's not going to change your results linearly. You have to do a little experimentation, a little math, but that makes it worthwhile. I'll get into, I have more little stories, but I'm going to move along into my last section. People enjoy manipulating hardware, and then you're a hobbyist or enthusiast. And when you're a government, it becomes spycraft. And I'll give you some examples. Can I use the board? You know, you got your traditional cigarette pack. Now, this is old. This is kind of a retro. It's a handmade device. And, you know, you're going out, you're friends with a bar. No one's going to think twice of seeing a pack of cigarettes that says holiday in Russian. And it looks good, and it's what you'd expect, and it has a nice little label in Russian that, you know, all kinds of things are hazardous to your health, and under the Soviet system, most things were hazardous to your health. And it'll pass as a regular cigarette case. You know, nothing suspicious there. Again, all handmade. You've got a nice little interesting device. You've got a shutter mechanism, Soviet-style winder,
Wow.
and
I'm sorry. Keep it like
right around here. And you can fire right through the cigarette case.
Slick.
And the best part, it actually holds a cigarette for you. Now,
Where did you get that?
Rome.
I mean, was this like I imagine they didn't sell these in the shops, did they? Or, I mean, this.
I have a friend.
I understand.
Now, moving right along. This is why some people use handles. A little more modern, we have things like this. Weighs about, well, between 40 and 56 grams. I think it's 40 grams without a battery, 56 grams with. Now, this is not for document imaging. Other models are, but it's still a fun little toy.
Was that all analog? There's no.
Oh, this is pure film. It takes 8mm film. It's over a 50-year-old cartridge. It hasn't been changed. You can get color or black and white film. There's also something. Some people will roll their own film, so you can use, say, microfilm film. You can use what they're calling gigabit film. You can use infrared film. All kinds of interesting applications.
Microdots?
Microdots, we can do a whole talk on that. But yeah, you can reduce images extremely small and hide them. You can take pictures of pictures, or pictures. You take a picture of something, and you take a picture of that, and you end up with an image 1/100th of an inch across, and they're very hard to control. Anyway, they're newer things, but these are interesting. Now, I'm going to talk about just two items involving spycraft and modified hardware. One is there was a modified calculator, TI-57 type or 58 series, that someone was using. I believe it was in Germany, and this was originated in Hungary. And
looking very similar to this. I might add, this is a Hewlett-Packard HP41, but it was basically the same kind of
similar
scientific
capability.
calculator.
Now, what they did was I use the term the bad guys modified it and put in secret codes. And if you entered the password into this, you could retrieve information relating to a series of meeting locations. Now, this was discovered. It was discovered by human intelligence. So we had contact on the other side who indicated this guy might be dirty. We had a friend getting close to him, just work with him, and the guy started bragging, and he showed off his nice toy.
Now, wouldn't he use that to decode? He used that to decrypt encoded messages that he might have received, like over 5 number groups over shortwave, or not?
Actually, it's very simple. It's just a series of meeting locations that was encoded on it. I mean, there's no need for something like that to use this fancy technology, but it's been done, and it would have been hard to find. And you don't have to explain little bits of paper with numbers lying around your apartment.
Right. I think the Cuban spies were caught recently. Last year, were using PCs doing that, but this was before PCs.
And I'll talk about something a little more modern. There's a modified photocopier that was discovered in a Soviet consulate, and they used a digital camera, and what they did was very clever. They recorded the images of all documents that were duplicated. Moreover, and this is the clever part, they had a digital camera which took a picture of the face of the person
That's great.
making the document copy. And this was discovered by the Soviets. I may have to use the term Russian now. I don't mean to be, indelicate. Okay. Now, this was discovered, and it was discovered through some relatively straightforward mechanisms. There was a service technician assigned to this specific unit, and they weren't quite as professional as the service to you person for the other photocopier. I'm not sure they even knew how to repair photocopiers. And when this was noted, the Soviets had the machine weighed to compare it to other units of the same type, and it came up heavy. And they proceeded to analyze it. There's one other interesting thing. In addition to document imaging, there's an old technique that was used. People have used small cameras to take pictures of documents, but when you use an old 8mm camera that's modified, you can take one picture per frame, and on a spool you can get thousands of images. Okay, anyway, I'll just mention, if I can, I'll just go on to my conclusion from my thoughts on hardware hacking and what playing with hardware means and comes to. And I read a paper recently on Moore's Law, with what transistor density doubles every 18 months. Well, my thought really is that what's done with computers and what's interesting and perhaps what's cool and what's worth remembering doesn't necessarily follow Moore's Law. The interest with any given technology doesn't necessarily double every year or 18 months. It's up to you to make these technologies interesting and worthwhile and remember what you did with them or what people did and to find value in it and say, hey, this was really neat, or certain things were really worth doing. And I'll pass it back to John in Cheshire.
All right, well, I'm going to try and fit in Q&A, so if you have questions about it.
We have 17 minutes.
Yeah, okay. But Cheshire, you have as long as you want to talk.
Okay, I'll just throw in a couple of comments about how we used to play with old computers. The first personal computer I got to play on was an Altair 8800. Now this is talking a personal individual computer. I've been playing on some time-sharing systems before that at science fiction conventions because the kids at the colleges would take the terminals, dial it back up to the schools and what have you. But the Altair 8800, the first time I worked on one, I had to go to the front panel switches and load in 24 steps, set the switches, push the load button. That loaded that instruction into the first memory space. Then set the switches again for the next word, which was 8 bits long, and then hit load 24 times. Then I could finally hit run and load BASIC off of paper tape from the Model 33 teletype attached to the machine. A couple weeks after this got going, and I got real good at those 24 steps and loading them in, we got a cassette drive in. And it was the 24 steps to load the cassette drive. Eventually, of course, people came up with the idea of programming EEPROMs with the 24 steps. Just load the address of the EEPROM, press run, it would then load BASIC that way. So we progressed with these early computers from the bad old days into better times. My first experience with an Apple was with an Apple I. I used to work at a computer shop on 39th Street near 6th Avenue called The Computer Store. Some folks in Boston had gotten a guy in New York to set it up, and I got asked to move to New York to help the guy out. While there, the local chapter of the IEEE, the Institute of Electrical and Electronic Engineers, invited me to bring my Altair 8800 to show up at their monthly meeting. Well, they also invited the guy from the Computer Mart on 30th Street in Madison, and a couple of other folks. And Stan Veet, who later went on to become the editor of Computer Shopper magazine, ran the Computer Mart at the time, and he brought an Apple I computer. It was basically, an Apple I was just the circuit board, and Stan had it mounted inside a backgammon case, and a small power supply that he plugged into the wall, jacked that into the Apple, and he ran that with a small TV monitor, and that was his Apple II. And I had the big, huge, clunky Altair 8800 with the S100 boards. These were circuit cards that would fit into the slots, and each card could be different things. We had the Krememco Dazzler, which could be programmed to run a kaleidoscope on a TV screen, and I think that was my demo. And that was a really fun night. We had a good time. When the computer store died, Stan hired me to work in the Computer Mart for a while. And we're still friends. Stan and Dee actually live in area code 321, and we're still buddies to this day. Run into each other in town every once in a while. Sometimes even at space shuttle launches down at Spaceview Park. So you can go to CheshireCatalyst.com, and you'll find links there to get instructions on how to see a space shuttle launch if you're ever down in Florida for that. Back to computers. One night in the computer store, I had a couple of hours where I was left alone. And my thing at the time was the telex network. Now, telex machines are Baudot-based machines, 5 bits, just like the telecommunication device for the deaf that Bernie S. displayed earlier. The teletypes were a 5-bit system, but modern computer terminals are the 7-bit with parity or 8-bit system, the ASCII code, American Standard Code for Information Interchange. The Baudot code is named for Émile Baudot of France, who first came up with it.
Or the Moore code, if you believe an American invented that code.
Okay. Depends which story. But the overseas telex all ran on 5-level Baudot, but over in America we not only had Baudot code on the telex network from Western Union, but AT&T had the Twix teletype network, and they explained that they did not have it connected to the phone system at all. Well, I debunked that because the 212.640 exchange at that time, no longer of course, is where all the Twix machines lived. And some of the numbers actually went to international record carriers like RCA Global Communications, ITT WorldCom, and they would convert from ASCII to Baudot and carry your message overseas and connect you to telex machines. Well, I sat down with a touch-tone phone, an acoustic coupler, and a ADM3 visual display terminal, the American Dream Machine, as the ads at the time said, and just started punching in random numbers into the 640 exchange. CBS Special Events, no, that's not it. FBI New York, no, that's not it. Western Union Infomaster, that's it! I found it! The Western Union Infomaster computer, so I could send a message to any telex machine in the U.S. as well as the overseas it already had. Now, what were those 4 digits I dialed? And after spending 3 hours finding it actually existed, I spent another hour getting that particular number back again.
Cheshire, behind you is the ADM3.
Ah, wonderful.
With the graphic board that...
Yep. Keyboard and display monitor. On the back was an RS-232 you plugged into your computer, and it was a complete terminal.
It was very cool looking.
Very cool. Yep. There should be one downstairs in the RetroComputing area. So. The glass teletype, yes, that's what we called them then. And a friend of mine then coined the term soft copy for when he looked on his display tube.
All right, well, does anybody have any questions? You have a microphone for questions. Oh, you do?
Okay, that's wonderful.
Oh, it's wireless.
Ooh.
Do you have any tips on like locating technical manuals and such for like these obsolete equipment?
Hamfests.
I've used eBay.
Yeah, eBay's good too these days.
For people who know what hamfests are, it's a good question. Look in, actually, maybe the best word is to go to nutsvolts.com. Nuts and Bolts magazine has a website where they list all the hamfests are basically flea markets for ham radio operators and other electronic enthusiasts who like to collect junk, like all of us. And you can find, I mean, I found this amazing calculator for for $10, and it's a pristine condition. You can find all kinds of amazing stuff at hamfests.
Yeah, I would like to mention that the SIM1 which you were showing, the output medium for it was an oscilloscope. On an oscilloscope you could generate individual characters.
Well,
text.
Even out through the serial? I mean, the I.O. was serial.
Yes, I think through the serial. I don't remember exactly. Because I worked with the predecessor of SIM1, which was KIM1. And I recently dug it up, and it's still working. So actually it has a data button and a go button, so you just put your address and you start running your programs. It had only 1K of RAM, and
the SIM1, the Rolls-Royce version, had twice as much memory, a whole 2,000 bytes.
So in this 1K of RAM, I am the co-author of one of the books on KIM, and somebody wrote, for instance, a complete chess program. My son
in 1K.
In 1K.
I'm impressed.
My son wrote a game of life for it. I wrote a chess clock for it. So it's just amazing what you could do with 1K.
Did you ever play Wumpus on your KIM-1?
Yes.
Oh, that was a great game. Hunt the Wumpus.
Yeah, there
Like
was
a
a
piece
book.
of-
David Allen,
the
Creative
caves.
Computing Magazine, man. Just
Good
spread
stuff.
Wumpus all over the place.
And you could do, there was a good Lunar Lander program there, too.
Right,
Good
played
good
with
stuff. Those are the days.
And I wrote a program which would duplicate TRS-80 tapes using KIM-1.
That's amazing.
That's great. Thank you.
Any other questions? Don't be shy.
Just can't see well through the projector. Yes, microphone over here.
We have 8 minutes left, so.
I'd just like to point out that on a
5
lot of
minutes, I'm
these
sorry.
older machines that use the tape cassettes, it's easy to copy software. You can just use a CD-ROM and make WAV files.
That's an idea. One of the interesting things with the cassette tape format for storing data back then is there were all these competing standards. Like the TRS-80, its data standard was not the same as like a Commodore PET audio cassette standard. A bunch of people got together, and what year was the Kansas City standard developed?
About 76.
76. A bunch of guys that
Kansas City
ran
standard.
small computer companies got together in Kansas City and came up with an actual standard. It was probably the first microcomputer standard ever developed. It was the Kansas City cassette tape format, and it was standard frequency shift keying type format, similar to the sounds you heard coming out of the TDD I demonstrated. And that was a good trend, but it didn't turn out to be that. The industry no longer cooperated much after that, unfortunately.
If I may, one neat trick with cassette tapes. I remember doing a 300 baud, and I don't remember what it took to do it at 1200 baud. But you could, besides logging any of your your dial-up sessions to bulletin board systems or other text-based systems, you could record the line, and then later, if you tell your computer to go into terminal mode and not to wait for a carrier, you could play the tapes back, and you have your sessions played back perfectly, so you could create and develop nice sets of logs.
I just wanted to mention a thing about FCC type approval. None of the stuff I showed here was FCC type approved, because it was before the FCC realized that computers were going to be a big problem as far as noise generation. And there was a neat, if you look on the back of a calculator or look on any computer, it's got this FCC type acceptance thing. And sometimes the FCC actually shuts down companies who make really crappy, noisy computers who generate a lot of radio frequency noise. But one of the cool things about all the RF noise these old computers generated, including the SIM1, and the TRS-80, you could actually write loops and throw an AM radio near the computer and actually write electronic music generation programs simply because of the RF harmonics that the program would generate, and that was a lot of fun. It was you didn't even have to hook the radio up to the computer. It was cool.
If I may, did anyone here hear the study, the program Elijah for Tempest or Tempest for Elijah?
Yeah.
Yeah, they've actually done something like that very recently with the electromagnetic. What's the term? You can get your monitor to play Elijah by playing with the scan frequencies through software, and it would come up on the radio.
That's hacking, folks. That's hacking, the true definition of it.
My adaptation is you could also then get it to transmit data.
I think we're out of time. Thanks for listening to this reminiscing, and enjoy the rest of the conference.
Thank you.